What if there was a technology the government was hiding from us? Something so game-changing, it would change how we live all of our lives.
That's pretty neat.
A technology that could put me in the government's crosshairs. That's right, I'm talking about a water-powered car. You may say that's impossible, and I counter with this. Mr. Hoover Dam was probably told the same thing, yet he still built the Hoover Dam, and now all of Las Vegas has power. So, am I gonna put a dam on top of a car? No, that's silly. It would never fit. I'm gonna put a water tower on top of a car. The idea is simple. Fill some elevated area with water, then have that water run through a turbine, generate electricity, and power the wheels. Alright, I don't actually have any of those things, but what I do have is something even better. A pile of what looks like junk. An empty soda bottle, $12 to spend on Amazon, and a disassembled RC car. The first step is going to be to fill our water tower with water. All done. Next we'll have to connect the water tower to the turbine using some tubing. Alright, so our tubing is connected to the turbine, which is connected to the car, and hopefully when water passes through the turbine, the wheels spin. I should flip this. Water should start flowing through. The turbine will spin, will generate electricity. Hopefully the wheels spin. Alright. Looks like water's flowing. Holy cow, it's not working. Wow, that is exciting. About halfway through the bottle now. The electronics are getting soaked. And our valve is falling apart here. And that's it. Nice. Alright, so why didn't our water car work? I know what you're gonna say. Why didn't you just add more water? Why didn't you just raise the water? Because that would be stupid. You need to understand gravity. You know that thing that's keeping you from benching 225? To understand this better, let's imagine some water tower. There it is. Now let's give it some height and some mass. Now, how much energy is in this water tower? I'm gonna guess mass times gravity times height. Oh my god, look at that. I'm right. Now you know where balls get their energy when they roll down hills. But Alec, you say, we could still just increase the mass or height of the water tower. See, that's where you're being misled. Okay, we need two things. A water tower and a Big Mac. What if I coded something that showed how many Big Macs worth of energy we have in the water tower? And we could change the mass or the height of the tower and see how that changes how many Big Macs we have. So we could finally see just how much energy we're getting from the water. So I got to work coding software that would make engineers at Google nervous for their jobs. So here's how it works. We have two knobs. One adjusts the amount of water, and the other adjusts the height of the tower. As we adjust the knobs, we see just how many Big Macs worth of energy we have in the tower as gravitational energy. Alright, so let's just go ahead and add some mass to our water tower, and then some height. What? My 600 calorie Big Mac has 600 calories? Or 2.2 million joules of energy? Yeah, in fact, our Big Mac has the same amount of energy as a water tower with the height of a football field and the mass of a Toyota Tacoma. Or, for my Americans, 4,000 F-150s raised 1 inch above the ground, or 2 10,000ths of a football field above the ground. Alright, back to the drawing board. I think it's time we cheat. We're gonna pressurize the water, and by water, I mean not water, and air instead. Instead of using gravity to pull the water down, we're gonna use air to push it down. Kind of like pushing a cannonball out of a cannon. What we need to do is fill some pressure vessel with air. But we won't stop there, because then we're gonna fill it with even more air. And then we're gonna fill it with even more air. This will give us a huge source of potential energy. So I designed a system to contain and regulate the flow of pressurized air using Fusion 360. And here's what I actually built. Laid out like a picture taken at the scene of a murder. We're gonna fill this bottle with water and air. And hopefully the air pushes the water out into the tube and then into the turbine. All right, I filled our jug up with water, and on the bottom, I drilled the hole and then covered it with silicone. So hopefully I can go through that hole and pump some air in there with this bike pump. I have no idea if this is gonna work. Oh my God, it's working.
Okay, it looks like the pressure's escaping. Get up to like 20 PSI. It's definitely bulging. I can't really get any higher than that. Everything just escaping. So let's try this. All right, so you can see that the water is filled on this side, and on this side is empty. So we got the valve connected here, and then when I open this, the water will flow through here into our turbine. Hopefully our wheels spin.
All right, let's invert this bad boy. Now we'll have gravity and pressure working with us. And open. Open. Oh my God. All right. Okay. Oh no, it fell apart immediately. No. Okay. Yeah, we have a problem. We have a very big problem. Ugh. Okay, it didn't work. What's new? Okay, once again, our water car didn't work. But I think I know why. When the water leaves the tank, the volume of air left behind increases. But when the volume increases, our air pressure decreases. So to start, the pressure in the bottle is bigger than the pressure outside the bottle, pushing the water out. But at a certain point, that flips as the volume increases. And now, the pressure outside the bottle is actually greater than the weight of the water and the pressure inside the bottle. And I think this is why our water stopped flying. I know what you're gonna say. Hey, why didn't that happen with the first bottle? Well, I knew that was gonna happen, so I drilled a hole in the bottom to keep the pressure equal. And I'm gonna let you figure out why I wouldn't want to drill a hole in my pressure vessel. And, you know, I could design a more complicated single flow ball valve, but I don't want to. I have a better idea. All right, I have one more idea. We're gonna take this high pressure, high flow rate hose, and we're gonna connect it directly to the turbine, and hopefully this will finally generate some electricity. Okay, I really hope this works. Turning on the water now. Right, water's flowing.
Spinning through the turbine. Wheels are not spinning. Let's see. Maybe if I start spinning them. Oh my God. Look at that, it's working. Look at that, the wheels are spinning. Water car. Now, they're spinning in opposite directions. And also, it's not high enough to get it moving. Also, even if they were spinning in the right direction, it's not enough to move the actual car. Look at that. Water car. That's working. That's a success. I mean, as soon as I put it down, it stopped working immediately. It's leaking like crazy.
Now, I know what you're thinking. Alec, you got a haircut. I did. Thanks for noticing. Okay, so what about the water car? Now, I think our water car was a success, and I see no way to possibly make it better, or any good reason to. Anyways, this was my first video, so please subscribe, like, and share. Bye.